Hello everyone, I'm Vivek from K4 Metrics and we support SmartUQ in India. We have done a series of videos on continuous response emulator, that is the emulator or surrogate model for continuous output variables. In this video, I will be introducing a different type of emulator called Spatial Temporal Emulator. This emulator allows us to handle problems where output is a function of spatial location and time. For example, you may be dealing with a problem where your output is temperature of a component as a function of location and time. Or in FEA, you may want to look at stress at particular locations. So for these kind of problems, we require spatial temporal emulator. I'll be using the same Naka airfoil example from SU2 tutorial, which I used for the continuous response emulator series as well. So this is our initial working folder. So I have a CSV file that contains input parameters. I have 25 slices of data and each slice has input parameters for 15 runs. I got this CSV file from the DOA option in SmartUQ. We have covered this in the first part of the continuous response emulator series. So I leave a link in the description so you can check it out. The remaining two files are the configuration file required by SU2 and the mesh file. We have chosen to work in such a way that when we run the script to solve the simulation in SU2, so it creates a folder for each slice and in turn it creates a subfolder for each simulation run. So you can see here that this is the slice 1 folder and it contains 15 subfolders, and each of these subfolders will have these output files. The one we have to look is the restartflow.csv file. So how we came from the top image to the bottom image is covered in part 2 of the continuous response emulator series. So for that also I leave the link in the description so you can check it out. So I open this restartflow.csv in Excel. So I'll show both the input and output data to you before getting into the emulator section. So I opened SmartUQ GUI and this is the first slice data that it contains 15 runs. So these are the input parameters and these are the number of runs here. Similarly, I have opened the output as well. So this restart flow.csv contains at first the point ID, that is the grid point ID, and the next two columns are the grid point coordinates x and y. And the remaining are 10 spatial variables: density, momentum x, momentum y, etc. So this is the value of density at grid point 1. This is the value of density at grid point 2, etc. Now SmartUQ requires the data to be in a different format. So SmartUQ requires you to have the variable as columns and the number of simulation as rows. So in this case, what needs to be done is here the density grid point 1 and the next cell should come as density at grid point 2, density at grid point 3, etc. So it should be in this format. Now in order to edit this, we have used a Python script. So this is the Python script we have used, and it first reads the restart flow.csv file and it reads all the data in it. So that is all the columns, rows, the 10 spatial variables, and the first thing that it will do is it will delete row 1 and then it will delete columns 1, 2 and 3. So let's take a look at what these are. So row 1 contains the names, point ID, XY and all those things, and columns 1 to 3 are just the grid data. Now this is not required as part of the output variable, so this is being deleted. And the row 1 is being deleted because when we transpose the matrix, this will cause the issue as this will become a column and it won't be in a format that is suitable for SmartUQ. So once these are deleted, it will transpose the matrix and then it will write the output to matrix by spatial.csv. So this is for slice 1. and DOE1. So this is repeated for the remaining 14 runs, and then it will be clubbed all together into a single output file. So with this, let me shift to SmartUQ. So whatever I have shown, that is deleting of columns, transposing the matrix, then adding or clubbing two files together either row wise or column wise, all this can be done within the SmartUQ as well. We have chosen a Python program to minimize the human error. So this is the input matrix as I showed earlier, and this is the coordinate matrix. So the column 3 is just a grid point number. The 1 and 2 are x and y coordinates. Since this is a 2D airfoil case, if you're working with a 3D case, you will have x, y, and z coordinates here. And this is the output matrix. So you can see that it had 15 runs, that is 15 rows. So the output matrix also has 15 rows. When it comes to columns, you can see that it has 52,330 columns. Why this is because the airfoil case has 5,233 grid points. And as I showed earlier, we have 10 spatial variables. So we get the value of those variables at each grid points. So 5,233 into 10. So it becomes 52,330 columns. So the columns are something like this. So it will be density at grid point 1, density at grid point 2, density at grid point 3, etc. till 5,233 columns. So after that, the next set of 5,233 columns will be momentum x, and it will continue further. So these three files will be used to create the spatial temporal emulator. So this concludes this video. If you have any questions, drop a comment down, or you can reach out to us at support@kfometrics.com.